This is a fun little problem where basically we're going to be looking at a situation and try to draw a couple of graphs that relate to it. So what we have here is this little guy, Dan, is on top of a ladder that's 2.5 meters tall. The ladder's next to one of those little individual trampolines that stands 1 meter off the ground. And Dan's going to jump onto the trampoline. Trampoline's going to push him up to a height of 3 meters before he then jumps back down and lands on the ground. And we're going to let f of t be his height off the ground after t seconds. Okay, so let's see if we can take a look at what this graph might look like. Okay, so this is t, this is f of t. Alright, so at the start, okay, Dan's going to be up here at the top of the trampoline, so he is at a height of 2.5 meters at time 0. Okay, that's where he's starting. Okay, he's going to jump off the trampoline, and his height is going to drop as he jumps, and at some point he's going to land on that trampoline, which has a height of 1 meter off the ground. Now, I don't know exactly when that's going to happen. Let's just call it time A, okay? Now, if you think about it, he's not going to spring back immediately because the trampoline's going to give a little bit, and his height above the ground is going to drop a little bit below 1 meter until he comes back to the height of the trampoline. I don't know when that is. Let's call that time B. And then the trampoline will push him upward, and it says it takes him to a height of 3 meters. So right about there. I don't know when that happens. Let's say time C. And then he falls to the ground, and as he does that, his height above ground will drop until the height above ground is 0 when he's on the ground, let's say at time t. So that's a pretty decent sketch of what the original function for his height above the ground would look like. Now, by using slopes of tangent lines, we can approximate what the graph of the derivative of that function would look like. All right, so this time we want to graph the derivative of this function. We're going to have information about the same times, 0, A, B, C, and D. All right. So at the start here, notice you've got a horizontal tangent line. So we're going to have a slope of 0. So the derivative there is 0. Okay. Now if you look, the slopes are negative all the way down to this point here somewhere between A and B, just a little bit before B, where we get another horizontal tangent line. So somewhere here between A and B, we get another 0 for our derivative. And between that, we have negative tangent lines. So the graph of the derivative will drop below the x-axis. All right. Okay, and then as I continue along, look at the tangent lines. They have positive slope, right? So that means that the graph is going to go above the x-axis until I get to this maximum height here at C, where I'm going to have another horizontal tangent. So let's see here. That means that the derivative goes positive, comes back down to another 0 for the derivative at C. And then for the rest of the graph, we have a negative slope of the tangent line. Okay, so kind of a rough graph, but by looking at the tangent lines to the original function, we can then sketch a rough graph of what the derivative would look like. So again, we've got this, cute little problem about the Dan jumping on a trampoline, and by what we know about what really happens, we can sketch a graph for the original function, and once we have that, we can sketch a graph for the derivative.